Hello, hello, chapter 2. You have made it. Congratulations. We are now looking at these linear equations in a different way. We are going to be graphing them. We're not talking about number lines, we're talking about coordinate planes. So, let's get to it. A linear equation is an equation whose graph is a line. Hence the name linear. Linear. The points on that specific line that we're going to be graphing are called solutions. Okay, so we're looking at equations that something like y equals negative 2x plus 1, where there's a lot of different values for x that will give you very different values for y. Like, for example, if I were to start graphing this particular equation with x values between negative 2 and 2, let's say I did negative 2, negative 1, 0, 1, and 2, all these different x values are all different things that I can put into this equation. And once they're in there, they evaluate on the right side, and it says y equals and some number. Now, those things are infinite because I can choose any x value I'd ever want. I don't necessarily have to do negative 2 or negative 1. I could do negative 1.375, negative 1.432. Or if I wasn't restricted by this domain, I could say negative a billion, negative 3 billion, and I could still get y values. So these lines, these equations, go on forever, and it's really quite cool. So let's take a look at how we're going to graph them. I have my x values that I've chosen. These are kind of like standard x values to choose, just because they give you, a pretty good idea on your coordinate plane. Gives you a little bit to the left in the negative x's, gives you a little to the right in the positive x's. Why don't I start putting in a coordinate plane here? Ugh, terrible at drawing straight lines. Yeah, that's not that's not gonna work. I'm gonna instead do this handy dandy little line tool here, which will help me out. However, I do want my lines to have color, which is fantastic. Boom. Handy dandy line tool. Look at how much easier that was. Anywho, so yeah, it gives me a little bit to the left here. Say that's negative 1, and then we'll say that this is negative 2. And this will be positive 1 and positive 2. It gives you a pretty good look of your graph. So now I want to figure out, what does it look like when I plug in that value? It's going to be negative 2. Oops, I want to thin that out again. Not that thin. Times x, which I'm saying is negative 2 in this case, and then plus 1. And in this case, it'll be negative 2 times negative 1 plus 1. In this case, it'll be negative 2 times 0 plus 1. In this case, it'll be negative 2 times 1 plus 1. And in this case, it'll be negative 2 times 2 plus 1. So now let's figure out. All of these things are supposed to evaluate to what y is, now that I've put the x value in. So when I evaluate this, what do I get? Negative 2 times negative 2 is 4. 4 plus 1 is 5. In my next one, I have negative 2 times negative 1 is going to be just 2. 2 plus 1, 3. Negative 2 times 0 is 0 plus 1, 1. Negative 2 times 1 is negative 2 plus 1, negative 1. Negative 2 times 2 is negative 4. Negative 4 plus 1, negative 3. Very, very cool. Now I need to take my x and my y and put them together to make an xy coordinate. So my x was negative 2. My y pairs up with a 5. My x on this one was negative 1. When I plugged it in, it pairs with a 3. That is a 3, even though it looks terrible. My x here was a 0, it pairs up with a 1. My x here was a 1, it pairs up with a -1. My x here was a 2, and it pairs up with a -3. So now that I have all of these points, I'm just going to plot them all. Okay? I am in this graph kind of doing 2 boxes equals 1. So when I plot my point -2, I'm going to go all the way over to here, and then 5. 1, 2, 3, 4, 5. It's way up here. So I kind of made my graph a little bit messed up there, but that's okay. -1, comma 3. I'm going to go -1 and then 1, 2, 3. And my next one is 0, comma 1. That'll be there. My next one is going to be 1, comma -1. So 1 over to the right, -1 down. My next one's going to be 2, and then down 1, 2, 3. So a very important thing to recognize here is that all of those points lined up in a line. Okay, if it doesn't line up in a line, we know that a linear equation should be a line. So if that doesn't happen, you have an issue. I'm going to put a nice line through it, arrows on both ends indicating that that line would stretch out forever, and that's my linear equation graphed out on a coordinate plane. Right, I'm simply choosing x values, plugging them in, and getting a coordinate plane, coordinate points x, y. Now, there are different things. Like this came out diagonally. Some come out horizontally or vertically. And that'll happen when your equation says something like y equals a number, y equals, say, 3, or x equals something like 2. This would be, where it says y equals 3, would be a horizontal line at 1, 2, 3. This one, x equals 2, would be a vertical line at 1, 2. Okay, so now let's take a look at how that works out. Let's say that I have, oh geez, I almost did the exact examples. Let's say, I'm going to make my coordinate plane, I have y equals -3. The fact that it says y means that it's definitely going to be a horizontal line. Now it's just a matter of where does that horizontal line go. I'm going to make my graphed line in red. So it's going to be at -3, which means when I'm graphing horizontally, it's going to be 1, 2, 3, horizontal line at 3. When I'm graphing vertically, over here, x equals 2, it's going to be at 1, 2. Vertical line at x equals 2. Right? I travel along the axis that I'm being told. Y equals 3 means I traveled along the y-axis, down 1, 2, 3, and did my horizontal line. When it was a vertical line, x, I traveled along the x-axis, 1, 2, and did a vertical line at 2. Alrighty? And our last piece is our real-life application. The wind speed, y, in miles per hour of a tropical storm is y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. Graph the equation. When does the storm become a hurricane? Well, this second part, we obviously need a little more information, which we are told, boom, right there. A tropical storm becomes a hurricane when the wind speeds are at least 74 miles an hour. Our equation is telling us wind speed. Alrighty, so here's what we have to do. First of all, we gotta graph it. That's our primary goal. So I'm going to go ahead and set up my coordinate plane here with my x and y axis. And once I have my x and y axis there, I'll be all set to go. So now I need to pick x values. Go back to black here. X is what? X is the number of hours after the storm. So, do I need negative values? No, I don't. Why would I even make a coordinate plane like this? I don't need negative values. I'm going to go ahead and I'm going to move this because I don't care about any of those negative things. I'm going to move it down like that. Now I'm looking at a coordinate plane that is mainly in the positive axis. It was silly of me to make it like that. So x stands for number of hours, and y stands for wind speed. So let's say 0 hours, 1 hour, 2 hours, 3 hours, 4 hours. Sure, sounds good. Let's see. Now when I plug that in, my y is going to equal 2 times 0 plus 66. Over here is going to be 2 times 1 plus 66. It's going to be 2 times 2 plus 66. 2 times 3 plus what? 66. And 2 times 4 plus 66. Very good. So now, what does the y actually evaluate to? Here it's going to be 66. Here it's going to be 68. Here it's going to be 4 plus 66, which is 70. Here it's going to be 6 plus 66, which is 72. Here it's going to be 8 plus 66, which is going to be 74. All right, so now let's pair up some x, y coordinate points. I got 0, 66 going on here, which is a fantastic point. I have 1, 68, which, that's an even better point. 2, 70, which is an okay point. It's not one of the better ones. I got 3 and 72, which, I mean, that is an exquisite point. And I have 4, 74. Boom. All right, so now let's go ahead and start plotting. I'm going to put them in red so they stand out a little bit more. And I'm going to go ahead and put a break in the graph here. That way I can jump right up to, let's say, 62, 64, 66, 68, 70, 72, 74, 76, 78. All right, so this starts at 60. So my first point is 0, 66. So that's 60, 62, 64, 66. That's 1 point right there. My next one is 1, 68. My next one is 2 and 70. 3 and 72. 4 and 74. Fantastic. So it looks like I have a nice linear graph here. I will put it in blue. Awesome. So that's the first part. That's part A. Fantastic. I didn't even realize I was having so much fun that I didn't even realize that I was actually doing part A. Part B asks, when does the storm become a hurricane? So when is it above 74 miles an hour? Well, after 4 hours it was at 74 miles an hour, so it looks like anytime after 4 hours. Very good. As long as we're all okay with that, I think I'm ready to end for today. So go through the assigned problems. If you have any questions, write them down. And I'll see you guys next time. Fare thee well.